All right, now, discriminant is part of the quadratic formula, so you already know this. I just wasn't calling it this. But the discriminant is what's under the square root that's the full quadratic formula right there at the top of the page. What is under the square root, not including the square root, is called the discriminant. So it's just the b squared minus 4ac. And if you know that value, it can tell you how many solutions your quadratic equation has and also the type of solution your quadratic equation has. So that's what we're going to run through today in this little table on the front. I know this looks very elaborate, but it's really not a big deal. So there's three things that number could be. It could be positive, it could be negative, or it could be 0. So each one of those situations will give you the number of solutions and the type, which is what we're going to go through. That's broken up into this little table. So I just put an example to go through this with you to show you how to find the discriminant. So I'm just doing b squared minus 4ac. That's all I'm doing. So this is set equal to 0. I've got x squared minus 16x plus 73. So I'm just going to plug these numbers in. I'm going to do negative 16 squared 4 times 1 times 73. All right, so if I ask you to find the discriminant, that's all you would do. Just type this, or you could figure out by hand too, but we just type this into the calculator. This is just what's under the square root, doesn't include the square root. So the discriminant, if I said, tell me the discriminant here, you'd tell me negative 36. So then that is going to match up with my description that the discriminant is a negative number.
This is 256 minus 292.
Uh-oh. Did you have... Does it look just like that?
Yes.
I might have to come look at it. It should be negative 36. I may have just typed something a little bit off. Okay, now that is the discriminant. And let me just do the full-on quadratic formula just real quick to the side so you guys can see, and I'm going to ask you a question. So full-on quadratic formula would be opposite of b, so it would be positive 16 plus or minus square root. And I know what would go under the square root because we just calculated that was the negative 36. And then the bottom would be 2a, so it would just be 2 times 1. Okay, so if you look at how I put that discriminant in there, that causes me to have a negative number under that square root. What happens if you have a negative number under a square root? What does that make you think of? I. Exactly. Okay, so if this is a negative number, that's the number that's going to go under the square root. So if that's negative, you automatically know you're going to have an I in your answer. So this, and this one's a nice one. This is a perfect square in imaginary land. So we could simplify that to be 6i. But I could do, bless you, I could do one more step too because I can divide everything there by 2. So the actual solution to that little example quadratic equation would be 8 plus or minus 3i. Now, the deal is the plus or minus is 2 separate answers. It's just a little shorthand way of writing it. So I have 2 answers. What kind of answers? It's either going to be real or imaginary. So because we have an I, it would be imaginary. So automatically, if you have a negative for your discriminant, in the actual quadratic formula, that would go under the square root. And so we're going to have to simplify that with an I. So if you get a negative discriminant, you automatically know you have 2 imaginary solutions. I actually found the solutions on that question, but if it just asks you for the number and type, you can just decide if that's negative, you got 2 imaginary. Now, on the side here, just to give you guys a visual, and these 2 graphs are neither one of them are this equation here. But I just have one that is a parabola that goes right side up and one that goes upside down. Visually, if you have imaginary solutions, and you graphed the quadratic equation related to what you were solving, it would not touch the x-axis. So that's what this says here, just no x-intercept. So if we had a graph, I don't have this one particular graphed here, but if we graph that on Desmos, if I graph y equals what I just wrote in that, or what I have as my example, it wouldn't touch the x-axis, so you have 2 imaginary solutions. Real solutions would touch the x-axis. Okay, now, second thing that is a possibility, please do me a favor. Change, this should say positive x squared. Well, it probably should just say x squared, but I accidentally had a negative in front of that. So fix that for me just real quick. And this is going to be an example of a discriminant that's 0. So again, if I just do that b squared minus 4ac, for this question, it'd be negative 8 squared 4 times, it should be positive 1. I made a typo on that, times 16. if you do this, you could do it by hand or you could do it on your calculator, maybe. So I'm going to do negative 8. Make sure if you're putting in a negative number to square it, you put the negative number in parentheses, and then you put the squared outside the parentheses, so that'll ensure that it becomes a positive, which it should. But you get 8, negative 8 squared 64 minus 4 times 1 is 4 times 16 is 64. So it's 64 minus 64. So the discriminant ends up being 0. All right, so as promised, this is 0. So if I full on just did the quadratic formula just to show this to you guys for this question, it'd be opposite of b, so it'd be 8 plus or minus square root. The discriminant would be what's under the square root in your quadratic formula. So I end up taking the square root of 0 here. Does anybody remember the square root of 0? 0. It's 0. 0. Can do it. All right, now, what's 8 plus 0? What's 8 minus 0? Same. So basically what happens here when your discriminant is 0, that basically cancels out that plus or minus, because if I add 0 or subtract 0, it's the same thing. So this would just be 8 over 2, and that can be simplified. That 4 is the actual solution to that equation. The discriminant being 0, though, means when I do that plus or minus, the plus or minus basically goes away, because we're adding and subtracting 0 is not going to change anything. How many solutions do you see there? 1. All right, now, what type of number is that? It's just a real number. As if it doesn't have an I, it can have a radical, it can be positive, it can be negative. As long as it doesn't have an I, it's a real solution. Now, visually what that would look like if you had a graph, and again, neither of these graphs match that equation or anything like that. It's just one goes up and one goes down to give you the visual here. But what this is going to have, it's going to have one place where the graph crosses or touches the x-axis in this case, and it's just going to be the vertex. So if that's the situation, if you graph that related quadratic, like if I graph y equals x squared minus 8x plus 16, the graph would just touch the x-axis on the vertex and nowhere else. So if you got 0 as your discriminant, you got one real solution. All right, my last one, my last example here. Again, I'm just going to do this. You don't have to keep writing this formula. I actually don't know why I'm doing that. I'm going to do 5 squared minus 4 times 1 times negative 6. And if you want to grab your calculator and check that out, or I'm just going to put it up here on the screen, bless you. Should get 49 when you do that. All right, so there's my discriminant. So that fits my requirement here for the last piece, which is that the discriminant is some positive number, right? 49 is a positive number. If you full on did the quadratic formula here, it'd be opposite of b, which would be negative 5 plus or minus square root of 49 over 2a, which would be just 2 times 1 for this example. And so I've got a positive number under the square root. Now, in this example, that's a nice perfect square. But what I'm saying to you here, the plus or minus would stay in place. So you are going to have two different answers. If I kept going here, I'd have 5 plus 7 divided by 2, which would give me what? 2 over 2, which would mean one of my answers is 1. And if I did negative 5 minus 7 over 2, negative 12 over 2, so that'd give me negative 6. So this one, because of the plus and minus, we have two answers, right? I have 1 and negative 6, so this is 2 answers, and then both of those guys are real numbers. If you were to see a graph of this, and again, these two graphs do not represent that equation that's written there, but if you have a positive discriminant, your parabola, if you graphed it, would cross the x-axis in 2 different places. This one that we did as an example would cross at 1 and negative 6. These are just a couple visuals. One's going right side up, one's going upside down. But if you have 2 real answers, you'd have 2 places the graph would cross the x-axis. Is anybody having a question? Okay, here's all we're going to do. I'm going to have you guys find the discriminant, so you might want a calculator for this. We're going to do b squared minus 4ac. Now, don't write this, you got it on the front, but I'm just going to show you. If that number is positive, you have 2 real solutions. If that number is negative, you have 2 imaginary solutions. And if that number is 0, then you have one real solution. So I have one of each in this example. So go through there, see if you can tell me the discriminant, like calculate the discriminant, and then just go over to the side there, tell me. What'd you get? Yes, ma'am. All right, so what'd you say for your number and type of solutions? Perfect. All right, is anybody having a question? I'm just going to abbreviate that. All right, just b squared minus 4ac. If it's positive, 2 real. If it's negative, 2 imaginary. If it's 0, 1 real. Okay, now, the question here is not find the time. It is just yes or no, is this going to happen? So this question says, the little picture of the girl tossing the tennis ball here, but it says Rachel tosses a tennis ball straight up in the air. She's about to serve. The height of the ball is in meters and time is in seconds. So this is a little different than the gravity formula we've been using. Like I'd have a -16. That's in feet per second. This is meters per second. So that's why that's -5. -5 meters per second is the force of gravity if you're working with meters instead of feet. And this is going to model the path of this lovely tennis ball. So again, this is a yes or no question. This is not like find the time it takes to do this. So this one right here says, will the ball reach a height of 4 meters? So what they're trying to say is we're going to plug in 4 for the height. So that's what I'm going to do real quick. So in place of that h of t, or height based on time, I'm just going to replace that with 4 real quick. So I'm going to do -5t squared plus 5t plus 2, just copying that equation. Now, I'm going to use the discriminant, and I'll show you how in a second to answer this question. But before I do that, you just have to set it equal to 0 real quick. So I'm just going to do one quick step. I need to move that 4 that I plugged in for the height before we talk about our a, b, and c values. So we'd get -5t squared plus 5t and then -2. Okay, now, just in general, if it's just like a yes or no, is this going to happen? If your discriminant, if your b squared minus 4ac is positive or 0, then your answer would be yes, because then it has a real solution. All right, if that b squared minus 4ac is negative, then your answer to the question would be no, because that means it has imaginary answers, so it means it doesn't happen in real life. So to use the discriminant here, just to help us answer this question, if I get a positive number or if I get 0, that means it has real answer, and we would say yes. If we get a negative answer, that means it has imaginary solution, so it can't happen in real life. So we're just going to do b squared minus 4ac here. For this question, it's going to be 5 squared minus 4 times -5 times -2. And again, it doesn't matter what the number is, it just matters if it's positive, negative, or 0. If it's positive or 0, we're going to say yes. If it's negative, then we're going to say no. Okay, so did the discriminant, I got -15, so this falls into this category. This is not possible, that has imaginary solutions, so it can't happen in real life. And then below, I'm just asking exactly the same question, but it says, will it reach a height of 3 feet? So the only thing that's different, or 3 meters, I'm sorry. The only thing that's different is we're going to plug in 3 instead of 4. The process for this would be identical. We're just going to have a different c value. So before you set this up in the discriminant, you got to make sure you set it equal to 0. So I got to move the 3 first real quick. So I get -5t squared plus 5t minus 1. And then we'll do the rest when we come back from lunch. Sorry, I didn't. Well, we got to set it equal to 0. Okay, now let me pull this back down. So remember, we're just saying yes or no. Can this happen? So if the discriminant is positive or 0, that means it has real solution. So we would answer yes. If we get a negative discriminant, that means it would have imaginary solution. So it can't happen in real life. So we would answer no. So if I try it out for this one, it's going to look really similar to the last one we just did. It's your b squared, so it'd be 5 squared, 4 times a is -5 again. The c value is different here, though, because the height was different that we were trying to see if the ball will reach. So that's going to be -1 now. So here, I'm just going to cheat here real quick and replace my -2 with a -1. Now, does not matter what the number is. If it's positive, which it is here, or if it's 0, then my answer would be yes. So this, since this is a real It's going to give me 2 real solutions if that's a positive number. So that means the ball will reach that height. Does anybody have a question? Okay, now, these bottom 2 problems are kind of application a little bit of, or not application, but thinking through the discriminant to answer the question. So they're going to give us the quadratic, but they don't give us the whole thing. It says we're going to find the value of b here. So I've got 2x squared plus bx. We're going to figure out a b value here, plus 18. That would make this have 1 real solution. Okay, now, if you remember what we were talking about before lunch, 1 real solution means my discriminant is what? 0. All right, so you can literally set this up and solve a little equation. They do give you the a and c values in the equation. We just don't know b, but I can set this all up. But if I have 1 real solution, my discriminant, which is your b squared minus 4ac, has to be equal to 0. So I can just set this up. We're going to do b squared for a value in that problem is 2, and c value in that problem is 18. So if I solve this little equation, that'll tell me the b value that will make this have 1 real solution if we can figure this out. So 4 times 2 is 8 times 18 is 144. And we could solve this tiny little equation. So I'm just going to add 144 real quick. And I would have b squared is equal to positive 144. How do I get rid of the squared? Square root. Okay, now what would you write as your answer? Plus or is super, super important. We introduced the square root. There are actually 2 answers to that question. It could be 12 or it could be negative 12. So I want the discriminant to be 0, right? So if I do my b squared, if I do 12 squared, 4 times the a value is 2 times the c value is 18, you can check it. But the same thing, if I do negative 12, when you square negative 12 and when you square positive 12, they give you the same thing. So that's why there's actually 2 answers to that question. It could be 12 or negative 12. Okay, anybody have a question? All right, now the last one's a little bit, it's the same type of a problem, but it asks you for 2 imaginary solutions. And I got a little bit different quadratic going on here. Now, if I have 2 imaginary solutions, that means I'm just going to abbreviate this, the discriminant is negative. Okay, so the way that I would represent that, I'm going to do b squared minus 4ac. To show that that would have to be a negative number, I'm just going to say has to be less than, not less than or equal to, but strictly less than 0. So any number that we could plug in here that would cause that to be less than 0 would be a negative number. So with what we've got in the problem here, I'm going to do b squared for a and c are both 5 in this question, but I would need this to be less than 0. That would mean that my discriminant is a negative number. All right, now, this is a little weird when you have an inequality and you have it being squared. So this is minus 100. 4 times 5 is 20 times 5 is 100. And I want that to be less than 0. Now, what I would tell you with here, we're solving an inequality. We get the plus and minus symbol if we take a square root of both sides, so this is a little weird. So what I would tell you to do is I would have you just look at a graph of this. And I want to think about, I'm just going to sketch you a little picture here. If I keep solving this, it's not going to make sense in terms of how I'm going to answer the question. But if I added 100 to both sides, right, and I took the square root, it would be 10 and negative 10. If I graphed y equals x squared minus 100, it would cross at negative 10 and it would cross at 10. So I'm just going to sketch you like a tiny picture of a parabola. This is not just 2 answers like it was in the last question. Pretend I did a better job drawing that. That looks horrible. It would cross at negative 10 and 10. So if I need my solution to be negative, I'd be wanting to talk about the part of the graph that was underneath the x-axis. Any x value in between these 2 is going to cause that discriminant to be negative. So there's 2 ways you can write it. If you want to do like a little interval like we've done before, it would go between negative 10 and 10, but it would not include 10 or negative 10. That would actually make the discriminant 0. any number between those two, like if I put in -5 or if I put in +4, any of those values, if you put them in for B, it would make your discriminant negative. The other way you could write that, we could just do like a little, an inequality. So I could say that the B value needs to be between -10 and 10. So that's just saying B is some number bigger than -10 but less than 10. Any number that falls into that range would make your discriminant negative. If it asks you for two real solutions, I would just flip the inequality symbol over and say that the B squared minus 4AC has to be positive, and it would look really similar to that. Does anybody have a question? Okay, that's all we're doing.